Right, we are going to have a look at acute angles. Acute angles are angles that are less than 90 degrees and greater than 0 degrees. So if we have an angle that is less than 90 and greater than 0 degrees, then we will have an acute angle. So what is a 90-degree angle? A 90-degree angle looks like this. This is called a right angle, which is equal to 90 degrees. Right. So an acute angle will therefore be less than 90 degrees. So there's your acute angle. And this angle could be, let's say, 57 degrees. And a smaller angle like that, which is, let's say, 17 degrees, will also be an acute angle. And an angle that is slightly less than 90 degrees, let's say 89 degrees or 87 degrees, that will still be an acute angle because it is less than 90 and still greater than 0. So if in a test we are asked a question such as what type of angle is 91 degrees? 91 degrees is not an acute angle because 91 degrees is greater than 90. So 91 degrees is actually an obtuse angle, which we'll have a look at just now. So 91 degrees will not be an acute angle because it is greater than 90. If they ask us what type of angle is 90 degrees, 90 degrees is not an acute angle because it is 90 degrees on the dot. It is actually called a right angle, as I showed you here. There is your right angle. So it has to be less than 90. It cannot be 90 or less. It has to be less than 90. So it isn't, our acute angles do not include 90. Right, so if we are asked what type of angle is 89 degrees, that would be an acute angle because it is less than 90 degrees. So 89 degrees is an acute angle, as is 1 degree, because 1 degree is greater than 0. Right, let's have a look at obtuse angles. Obtuse angles are greater than 90 degrees, but they are less than 180 degrees. So obtuse angles are greater than 90 but less than 180. So obtuse angles will look, so there's our right angle again. Remember, a right angle is 90 degrees. And if we look at an obtuse angle, the angle will be a bit wider. Right, so there's an example of an obtuse angle. So let's list some examples here of obtuse angles. It has to be greater than 90 but less than 180. So like what we saw earlier, 91 degrees is an obtuse angle. It could also be 179 degrees. It could be 150 degrees, and so on, as long as it is greater than 90 degrees but less than 180 degrees. So again, let's have a look at if we were asked what type of angle is 90 degrees. 90 degrees is a right angle. So 90 degrees on the dot will not be an acute angle, and it will not be an obtuse angle. It is on the dot 90 is a right angle. Okay, but if we have a look at an angle that is greater than 90, such as 93 degrees or 91 degrees, so if it's just greater than 90, it will be an obtuse angle, right, because that is still less than 180. If we have a look at 160 degrees, it will be an obtuse angle because that is greater than 90 but less than 180. If we have a look at 179 degrees, that will be equal to an obtuse angle because it is greater than 90 but less than 180. So if we have a look at 180 degrees on the dot, is 180 degrees an obtuse angle? No, it is not, because obtuse angles have to be less than 180. And 180 is not less than 180. 180 is 180. And a 180 degree angle is called a straight line. And that is because a 180 degree angle looks like this. It goes from one point over to another point. So there's your center point. And if you were to measure this angle, it just forms a complete straight line. So 180 degrees is equal to a straight line, and 90 degrees is equal to a right angle. And you can see that your right angle is equal to half your straight line. So if you were to draw a line that is perpendicular to your straight line there, you will form a right angle. You would form two right angles. So two right angles will give you one straight line, or one 180 degree angle. Right, we're going to have a look at reflex angles. Now, a reflex angle looks, you need to label it correctly because it can look a bit like an acute angle or an obtuse angle, but it's actually the outside bit of that acute or obtuse angle. So reflex angle is greater than 180, greater than our straight line, or 180 degrees, because a straight line is equal to 180 degrees, but it is less than our full revolution, which is equal to 360 degrees. So our full revolution is equal to 360 degrees, so it is less than a full revolution, but it is greater than 180 degrees. So if we have a look at our 180 degree line there, if we have got an angle that looks like this, so there's an obtuse angle, but on the outside there we have got a reflex angle, because you can see that going from here all the way around to there, it is greater than our straight line. It goes past our straight line mark. So that makes this angle a reflex angle because it is greater than our straight line. And our 360 degree angle, so if we are going from this point here, and we can think of a clock, so we're going from 12 o'clock all the way around back to our 12 o'clock. So that gives us a full revolution. So that means that 1 hour has passed. 1 hour has passed if that was our minute hand moving from, so if there's our minute hand moving from 12 o'clock, so let's say it was 3 o'clock, there's our hour hand on our 3, so that 12, that minute hand will go from the 12 all the way around and go back to our 12 when it becomes 4 o'clock. Right, So that is called a full revolution. So any angles around a center point. So if we've got a whole lot of angles round a center point, then so there's our center point. So the sum of all these angles will be equal to 360 degrees. So angles around a center point will be 360 degrees. And a full revolution, which means going from one point all the way around to another point, will give us a 360 degree angle, which is called a full revolution. So we need to remember that reflex angles are less than our full revolution. So if we have a look, let's draw, we've got a clock, and if our minute hand there moves from 12 o'clock and it ends up getting to 11 o'clock. So we end up going all the way around and we end up there. So this is what our angle will look like. We'll go all the way around and we only end up there. So this angle here, going from that center point all the way around, so that angle there is called a reflex angle because it is less than 360, but it is greater than 180 because it passed our 6 o'clock or our 6. Our minute hand passed the 6, which means it passed our 180 degree line. That means it's greater than 180, so it is a reflex angle. So what type of angles are reflex angles? Or let's give some examples. So greater than 180, so 181 degrees will be a reflex angle. We could also have 195 degrees. We could have 359 degrees because 359 is less than 360. 360 degrees, however, is called a full revolution. So 360 degrees on the dot is equal to a full revolution, and 180 degrees on the dot, as we've learned, is equal to a straight line. Right, so 360 degrees is not a reflex angle because a reflex angle needs to be less than 360. And at the moment, if we consider 360 degrees, that is not less than 360 degrees. It is 360 degrees. So we call it a full revolution. It is not a reflex angle. And our 180 degree angle is a straight line. So a 180 degree angle is not a reflex angle either. Right, adjacent angles are angles that share a common side. So there's a common side and a common vertex, which means a point there. Those three lines join at that center point, which is called a vertex. So because there is our common side, there are our two adjacent angles. So adjacent angles share a common side, which will be in between them, and a common vertex and a vertex. So those are your adjacent angles. And then let's have a look here. These are called vertically opposite angles. So if I put a circle there and a circle there, I'm indicating that those two angles are equal to each other. Those two angles are equal to each other. And if I put a cross there and a cross there, I'm saying that those two angles are equal to each other. So when two straight lines intersect or bisect, we know that opposite angles will be equal. So because these lines here are straight lines and they are bisecting, it doesn't matter the angle that they bisect at, as long as they are two straight lines that are bisecting. These opposite angles will be equal, and these opposite angles will be equal. So these are called vertically opposite angles. Right, and vertically opposite angles are equal. Right, supplementary angles are angles that add up to 180 degrees. So they add up to 180 degrees. So this angle here and this angle here will equal 180 degrees. So if this angle is 40 degrees, we will know that the other angle is going to be equal to 140 degrees. And we can obviously see that because these angles are lying on a straight line, and we know that a straight line is a 180 degree angle. So a 180 degree angle, if it is divided up into 40 degrees, the other part of that angle will obviously have to be 180 degrees minus 40, which is 140 degrees. So supplementary angles add up to 180 degrees. If we have a look here, this is a right angle. So if in this right angle we have two angles, so let's first get rid of that right angle. So we've got one angle here and we've got another angle there. Because we know that this is a right angle, these are called this angle here and this angle here, they are called complementary angles. Complementary angles. Right, and complementary angles add up to 90 degrees. So the sum of complementary angles is equal to 90 degrees. So when you add your complementary angles up, we end up with 90 degrees. So if one of our complementary angles is 70 degrees, we know that the other angle is going to have to be 20 degrees, because 70 plus 20 will give us an answer of 90. So complementary angles add up to 90 degrees. Right, parallel lines are these lines over here. The distance between parallel lines will remain the same over their entire length. No matter how far you extend them, the distance between them will stay the same. They will never meet. Right, so they have to be straight lines that never meet. The distance between them will stay the same. So those are your parallel lines. Let's have a look at perpendicular lines. Perpendicular lines are two straight lines that intersect at a right angle or at 90 degrees, because remember, a right angle is equal to 90 degrees. So they intersect at a right angle, or they can just bisect here at a right angle at 90 degrees. So perpendicular lines meet at a right angle. And remember that a right angle is 90 degrees. So those are your perpendicular lines. We are going to have a look at corresponding angles. Corresponding angles are angles that, when we are working with parallel lines, form an F. Okay, so we are looking for an F. So there is our F, and underneath our F, those two, underneath the arms in our F, those two angles will be equal. So these lines here are parallel, and therefore this line that is intersecting our parallel lines will create a shape that looks a bit like an F, and there are the two angles that are equal to each other. And what you'll be able to see is that there are lots of different F's that you can find. We've got an upside down F over here, and that means that these two angles will be equal. We've got another upside down F over here, and that means those two angles will be equal. And we have got a backwards F over there, which means those two angles will be equal. So our corresponding angles create the shape of an F. When those two lines are parallel, these two angles will be equal. Right, let's have a look at our alternate angles. So we've got alternate angles. And with our alternate angles, we are looking for a Z or an N shape. So with our Z or our N shape, we are wanting, so those two lines have to be parallel, or those two lines there. And if those two lines are parallel, then these angles there will be equal, and these angles will be equal. So we are looking for an N or a Z shape with our parallel lines. So there are parallel lines, and we can find a Z shape there, which means that those two angles there will be equal. If we have a look, we can find a backwards Z there, which means that those two angles will be equal. And so it continues. You will be able to find a few different N or Z shapes in order to find your alternate angles, as long as you remember that as long as these lines are parallel, these alternate angles will be equal to each other. Right, let's have a look at our co-interior angles. Okay, so our co-interior angles are angles that create a U or a C. So we've got a U or a C type shape. So if these sides are parallel to each other, these angles here will not be equal, but they will add up to 180 degrees. Right. So if these two sides are equal, these interior angles will not be equal. They will add up to 180 degrees. So if these sides are, or if these lines are parallel, then we need to look for our C shape or our U shape. So these angles here will only be equal if they are both equal to 90 degrees. So that's in the case of having half a square or half a rectangle or something. We end up with two 90-degree angles, and therefore they will be equal to each other, but that is just because 90 plus 90 equals 180. So either way, the sum of your co-interior angles has to be equal to 180 degrees. So we can see that we've got co-interior angles there, and so the sum of those has to be 180 degrees. and we've got a backwards C or a sideways U there, and that means that these two angles will add up to 180 degrees. So these are your corresponding, your alternate, and your co-interior angles, and we can remember them as the fun rules. And if you want to write your fun with more straight lines, you can do that as well, because you have to remember that it's working with parallel lines. So you can remember them as your fun rules, your corresponding, your alternate, and your co-interior angles.